Hello guys, in this video I will focus on the mathematical calculations related to flying shear. Since the saw moves diagonally relative to the product line at an angle theta, its velocity in the line direction is equal to Vs multiplied by the cosine of theta. I will refer to this velocity as VSL. The product line velocity is measured using a master encoder. The master encoder shaft is mounted on a disc, which is connected to another disc via a pulley. The second disc remains in direct contact with the product, ensuring accurate velocity measurement. This installation has two key advantages. First, it reduces the impact of vibrations on the encoder shaft. Second, if the product is hot, it does not damage the encoder, as the encoder is positioned at a safe distance from the product. As shown in the diagram, the vertical axis represents the saw velocity in the line direction, or VSL. The horizontal axis represents the measured distance traveled by the product, which is measured by the master encoder. The saw's movement in a single cutting cycle follows 5 main phases: waiting, accelerating to match the product line velocity, cutting, decelerating to stop, and returning to the starting position. To simplify, let's focus on the moment the saw makes contact with the product. At this point, its speed should already match the product line velocity. The saw continues cutting until it passes the product's edge, then slows down to a stop. After stopping, it returns to the starting position. The final step is waiting and preparing for the next acceleration, with the waiting time depending on the product length, which will be calculated. As a result, the product length is equal to measured product movement by master encoder during one cycle. However, in practice, we must account for an error parameter to adjust the cutting length. As I mentioned earlier, DS1 represents the waiting time. DS2 and DS4 depend on the product line velocity and saw acceleration, while DS3 depends only on the product line velocity. Meanwhile, DS5 can be fixed based on the maximum saw velocity to return to the starting point as quickly as possible. This means that adjusting the final product length is only possible by modifying the waiting time, or DS1, and from this equation you can determine the value of DS1. I rewrote the equation this way to make it easier to reference. The calculation of the DS sum is straightforward. It is equal to the distance measured by the encoder from the moment the saw starts moving and accelerates to cut the product until it reaches the starting point again. This is the main concept of calculation in a flying shear system.